Everyone, welcome back to the channel. In today's video, we are going to discuss polymorphism, another fundamental concept in Java object-oriented programming. We'll explore what polymorphism is, how it works in Java, and dive into topics like compile time polymorphism, runtime polymorphism, method overloading, method overriding, and the final keyword. By the end of this video, you will have a solid understanding of how polymorphism helps in writing flexible and maintainable code. Let's jump in. Polymorphism in Java means many forms. It allows objects to be treated as instances of their parent class rather than their actual class. Simplify put polymorphism enable us to define one interface and have multiple implementations. This is especially useful in scenarios where different objects can perform similar tasks but in their own unique way. For example, imagine you have a bird class and subclass mm, sparrow and eagle. Both birds can fly, but they fly in different ways. Polymorphism allows us to invoke the same fly method on both objects and they will behave according to their own implementations. Okay, compile time versus runtime polymorphism. Java supports two types of polymorphism, compile time and runtime. Compile time polymorphism is achieved through method overloading where the method to be executed is determined at compile time. Runtime polymorphism is achieved through method overriding where the method to be executed is determined at runtime based on the object's actual type. Okay, let's start with method overloading, which is an example of compile time polymorphism. Method overloading allows a class to have more than one method with the same name but different parameter list. The compiler decided which method to call based on the method signature. Okay, walk through an example. In this, imagine we have a class calculator with the two overloaded add method, one that add two integer and one that add three integer. The correct method is chosen based on the number of parameters based during the method call. Overloading helps makes your code more flexible by allowing methods to perform similar actions with the different inputs. Method overriding, which is an example of runtime polymorphism. Method overriding allows a subclass to provide its own implementation of a method that is already defined in a superclass. This is particularly useful when the subclass needs to modify or enhance the behavior of a method inherited from the parent class. Imagine the animal class has a method make sound which is overridden by the dog and cat classes. When we call the make sound method on a dog object, it will execute the overridden method in the dog class, not the animal class. Since the method is chosen at runtime based on the object type, this is called runtime polymorphism. Okay, now let's talk about final keyword. In Java, the final keyword can be used to prevent method overriding. If a method is marked as final, it cannot be overridden by any subclass. This is useful when you want to ensure that certain method in a class should remain unchanged and maintain their original behavior. For example, the method show message is marked as final in the parent class. If we try to override this method in the child class, the compiler will throw an error. Okay, let's bring everything together with an example of polymorphism in action. We have a parent class shape with a method draw. and subclass circle and rectangle that overrides this method. Polymorphism allows us to create an array of shape objects, and even though we call them same draw method on each object, it will behave differently based on actual type of the object, either circle or rectangle. This demonstrates the power of unique runtime polymorphism, but the method to be executed is determined by the object type at runtime. Let's quickly recap what we have covered. Polymorphism allows one interface to be used for multiple types of objects. Compile time polymorphism is achieved through the method overloading, whether the method is determined at compile time. Runtime polymorphism is achieved through the method overriding, whether the method is determined as runtime. Use the final keyword to prevent method overriding, ensuring certain methods remain unchanged. Polymorphism helps us write flexible and maintainable code by allowing objects to be treated as their parent class while still providing the unique behavior. That's it for today's video on polymorphism in Java. I hope this video helped you to understand the concept clearly. Polymorphism is an essential part for Java, making it easier to build scalable and adaptable applications. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more Java tutorials. See you in the next video.